This is AP Calculus 5.4, and in this section we're going to use the first derivative test to find all relative or local extrema, which means to find the relative maximums and minimums of a function. And I'm going to show you this based on just a simple graph, and then we're going to move into doing it algebraically or using our calculus knowledge. So if you look at this function, here we can determine, just by looking at the graph, that this function is increasing as x goes from negative infinity until it gets to, it looks like the maximum value there is at -1. And the function is decreasing from the x value -1 to 1, because that looks like that's where the relative minimum would be. And then again, it's increasing from x equals 1 to infinity. So we've already determined in the last section increasing and decreasing values. To figure out where a function has a relative maximum or minimum, those are going to be the values or the critical values where the function changes from increasing to decreasing or from decreasing to increasing. So algebraically or using calculus, we can find that based on anywhere a function changes direction from increasing to decreasing. So here we know by how to justify this based on the derivative. If the function changes from increasing to decreasing, then we have a relative maximum at that x value. If the function changes from decreasing to increasing, then we have a relative minimum at that x value. So before we used our charts to just figure out where the function was increasing or decreasing, we're going to do the same thing here. We're going to find our critical values, we're going to set up a chart, figure out where the functions are increasing and decreasing, and then we're going to take it a step further. If it changes from increasing to decreasing, then we know we've got a maximum at that x value. If it changes from decreasing to increasing, then we know we have a minimum at that x value. So it makes it really easy to algebraically find all your maximums and minimums using the first derivative test. We're going to find all relative extrema of the function f of x equals x to the fourth plus 1 over x squared. So the first thing we're going to have to do is find the derivative. Now you might be tempted to use the quotient rule there, but I know that it's going to be a lot easier to find the derivative of that one if I just change what it looks like. So I'm going to rewrite that function as f of x equals, and I'm going to divide each of these by x squared. So I would have x to the fourth divided by x squared is x squared, plus 1 divided by x squared is x to the -2. That's a lot easier to find the derivative of than using the quotient rule there. I'm going to find the derivative first. F prime of x is equal to 2x minus 2x to the -3rd. And then if I rewrite that, I have 2x minus 2 over x cubed. And then to get a common denominator, this needs an x cubed, so that's going to make that x to the fourth. And so I'm going to have 2x to the fourth minus 2 all over x cubed as my f prime of x function. The next thing I have to do is find my critical values. Remember, your critical values are anywhere that f prime of x equals 0 or where the function is undefined. So in order to find my critical values, I'm going to set the numerator equal to 0, and I'm going to set my denominator equal to 0. So here, that gives me x equals 0, and here, 2x to the fourth equals 2. If I divide by 2, I have x to the fourth equals 1. And if I take the fourth root of that, I know that x is going to give me a positive and a -1. So my critical values are at plus and minus 1 and at 0. The next thing I need to do is set up my intervals to determine where my function is increasing and decreasing and see what's happening here. I'm going to set up the first interval going from -infinity to -1. My second critical value was at 0, so I'm going to set up another one from -1 to 0. My third is at 1, so I'm going to set an interval up from 0 to 1, and then my final would be from 1 until we get to infinity. I'm going to pick a value within each of those intervals to plug into my f prime function. So here I'm going to choose -2, and I just try to choose the simplest numbers I can think of. Here I'm going to do -1/2, here 1/2, and of course you could put -0.5 and 0.5, that's fine. And here I'm going to use a value of 2. Then remember, to determine where the function is increasing and decreasing, we need to plug these values into the first derivative. So I'm going to plug these into f prime. So if I plug -2 into my f prime function, I'm going to use this right here because remember, we're just determining where it's positive and where it's negative. We don't need to find the exact value there. So if I use this, I can determine positive and negative based on what the numerator and denominator are. So if I plug -2 here, I'm going to end up with a positive on top and a negative on bottom. So my f prime will be negative. If I plug in -1/2 here, -1/2 would give me, let's see, -1/2 to the 4th power would be a positive 1/16. So that's 1/8 minus 2 would be a negative over a negative would be a positive. If I plug 1/2 in, I'm going to have, let's see, 1/16 or 1/8 minus 2, that's a negative over a positive, so that will be a negative. And if I plug 2 in, I'm going to have a positive over a positive. So that again would be positive. So my function is decreasing here, increasing on that interval, decreasing again, and increasing. Now, at first glance, you might think you have 1, 2, 3 maximums or minimums, relative maximums or minimums, but we have to consider what happens with this function at these critical values. And if you think about that, if you look at the original function, don't we know that there's going to be an asymptote at x equals 0 because the function itself is undefined at 0. So we cannot say that because this changes from increasing to decreasing that we're going to have a maximum at 0. So you have to be very careful here. Right here at x equals 0, that's a vertical asymptote. So the function is undefined and it is a critical value, but just because it changed from increasing to decreasing there does not mean that the function has a maximum there because the function is not defined at x equals 0. Remember, you can't have maximums and minimums where the function is undefined. You have asymptotes at those points, or you have holes in the graph at that point. So now looking at the rest of these, this function is decreasing on the interval -∞ to -1 and increasing on the interval from -1 to 0. Since it changed from decreasing to increasing, we're going to have a minimum value. So we have a minimum at the x value of -1. It changes from decreasing to increasing at the x value 1. So if it changes from decreasing to increasing, again, that's another minimum value. So the x value of that minimum is at 1. And then to determine the y values, because they've asked us for the extrema, they want the ordered pairs where the relative extremas happen, we're going to plug those values back into the original function. So if I plug -1 here, -1 to the 4th is 1 plus 1 is 2 over 1, so that will be 2. And then if I plug 1 in, 1 plus 1 is 2 over 1, again is 2. So we have two relative minimum points at -1, 2 and at 1, 2. And since the function is undefined at 0, we have no maximum values. So again, I wanted to make sure I showed you one that has an asymptote so that you don't get confused and think automatically that that's going to be a maximum or minimum, or just because the function changed from increasing to decreasing. There are going to be special cases that you have to pay close attention to. This one says find all maximum and minimum points for the function f of x equals x to the fourth minus 2x squared. This one's not quite as difficult. We know by looking at this one it's not going to have any asymptotes. So this one's going to be very straightforward. I know by looking at this that it's an x to the fourth. It's going to have 3 curves. So possibly have more than one maximum and minimum just based on what it's showing me there. So the first thing I'm going to do is find the derivative. F prime of x is equal to 4x cubed minus 4x. I'm going to then set that derivative equal to 0 to find my critical values. When I do that, I can take out or factor out the 4x. So I have x squared minus 1 left. When I set each of those equal to 0, I have x equals 0. And here I would have x squared equals 1, so I know x equals plus and minus 1. To set up my table of values, my lowest x value here is -1, so I'm going to go from negative infinity to -1 for my first interval. The second interval goes from -1 to 0. Third interval from 0 to 1. And the last interval from 1 to infinity. And the more of these intervals you set up, the easier they're going to get. I'm going to pick values within my intervals, -1/2, 1/2, and 2. And I'm going to plug those values into my first derivative. So when I plug into my first derivative, I'm going to again plug into the factored first derivative because it's going to be easier to tell whether this function is positive or negative at that f prime value. So -2, if I plug -2 in, this will be a negative and this will be a positive. So negative times positive is negative. If I plug -1/2 in, I'll have a negative times a negative, which is a positive. If I plug 1/2 in, I have a positive times a negative, gives me a negative. And if I plug 2 in, positive times positive is a positive. Again, we don't have any vertical asymptotes to deal with here. So it is safe to assume that anywhere it changes from positive to negative or negative to positive, we do have a relative extrema. Here, it changes from a negative to a positive. I like to draw this so I can visualize whether it's maximum or minimum rather than having to memorize things. Positive to a negative, a positive slope to a negative slope looks like that. So that looks like that's going to be a relative maximum. And then a negative to a positive looks like we're going to have another relative minimum. So we have relative minimum values at our x values of -1 and 1. And we have relative maximum values at the x value of 0. And to find those final ordered pairs, I would need to plug these x values into my original function. So if I plug -1 in, -1 to the fourth is 1 minus 2 times 1. So 1 minus 2 is -1. So we have a relative minimum at -1, -1. To plug 1 in, I would have a 1 minus 2. So that again is a -1. So there's another relative minimum at 1, -1. For the maximum, if I plug 0 in here, we would get the point 0, 0. Here the directions say to use the first derivative test to find all relative extrema. In the first one, it's giving you a trig function to deal with. So do that using trig function derivatives, and notice here the interval that they want you to use is the closed interval from 0 to 2 pi. So you're only going to use one revolution around the unit circle so that you have distinct values. You're not going to have an infinite number of values. And then for the next one, it's going to use the chain rule to deal with the intervals and finding your maximums and minimums. The method for these is exactly the same, so I want you to go ahead and pause the video, see if you can do these on your own, and then I'll give you the answers in a few minutes. So for the first one, the derivative of x is 1, 2 sine x is 2 cosine x. I set it equal to 0. That function 2 cosine x equals -1, so cosine x equals -1/2 at 2 places, at 120 degrees and at 240 degrees. 120 degrees is 2 pi over 3, 240 degrees is 4 pi over 3. Since this interval is given to you in radians, you need these in radians. If this had been from 0 to 360, then you could use. So my critical values are at 2 pi over 3 and 4 pi over 3. And then I set up my intervals from 0 to 2 pi over 3, 2 pi over 3 to 4 pi over 3, and 4 pi over 3 to 2 pi, dealing with the closed interval that they gave us. At pi over 2, or I chose a value between these. I chose pi over 2. Your quadrantal angles are going to be the easiest ones to choose because you're going to get zeros and ones or negative ones. So it's going to be really easy to determine what's positive and what's negative if you use those values. So I used pi over 2 for that interval, pi here, and 3 pi over 2 for this one. I found that f prime is positive, making that interval increasing. I found here that f prime was negative, saying that that interval decreased. And then in this interval, it was a positive, which meant it was increasing. There are no asymptotes in this trig function, so I don't have to worry about anything being undefined. So I can say that I have, it's increasing to decreasing here, so I have a maximum, and it's decreasing to increasing there, so I have a minimum. So my maximum value was at 2 pi over 3, 3.826. I just used my calculator to get that value. And then my minimum value is at 4 pi over 3 and 2.456 for my minimum value. Again, I use my calculator to get that. It's perfectly fine to do that. The next one involves the chain rule. I found the derivative using the chain rule here. Ended up with 2/3 times x squared minus 4 to the negative 1/3 times the derivative of the inside, the 2x. Remember, when you're dealing with a chain rule, don't forget to take that derivative of the inside part. That's very important. And then I just simplified it. I made it a fraction. So the 2 times 2x is a 4x. And then on the bottom, I made that a cube root to make the numbers easier to plug into. I set each of those equal to 0. And when I do that, I get x equals 0 and x equals plus and minus 2. Notice the original function did not have any asymptotes, so it's perfectly fine for my denominator to equal 0. Remember, your critical numbers are anywhere that the derivative is equal to 0 or the derivative is undefined. But notice the original function did not have a denominator, so that does not mean that these are asymptotes. That would be a common mistake I see. So these are all critical values. And if I use those critical values to set up intervals, I'm going from negative infinity to negative 2, negative 2 to 0, 0 to 2, and 2 to infinity. I chose some values within those intervals, and then I plugged those into my derivative. So when I plug negative 3 into my derivative, I ended up with a negative. When I plug negative 1 in, I ended up with a positive, a negative, and a positive for the other two intervals. So showing that it's going from decreasing to increasing, that would be a minimum. From increasing to decreasing would be a maximum. And then I have another minimum at the 2. So my minimum values are at negative 2, 0, and 2, 0. Remember, to get the ordered pairs, I just plug those x values into the original function. And then my maximum was at 0 and cube root of 16. I didn't use my calculator there, but you could certainly get that as a decimal instead of the cube root of 16. That would be perfectly fine.